All right, section 5.3 is on trigonometric functions on a unit circle. In order to learn the information in the section, you have to understand that a unit circle is a circle that has a radius of 1. So, like for instance, right here, that's a measurement of 1 unit. This is applicable because what we've done is we've taken what we know about an angle, that it starts in a standard position, and we put it with a unit circle, understanding that that point right there would be x and y. We already know that on a coordinate plane. So the distance across here is x, and the distance up here is y. So therefore you can sit there and you can go, okay, if I'm standing right here and I'm talking about trig functions, the sine of theta, which this would be theta, my unknown, is y over 1 because it's opposite over hypotenuse. So it's y over 1, or we always know that our y value on a unit circle is the sine of theta. So that y, think of y with sine. Then if I want the cosine, which is adjacent over hypotenuse, it's x over 1, or just x. So my x value is my cosine value. So always associate your cosine with your x and your y with your sine. So I can know all of my trig functions on this unit circle. I already said that my sine is y over 1. My cosine is x over 1. My tangent would be opposite over x, opposite over adjacent, or y over x. These, of course, are the reverse. 1 over y, 1 over x, and x over y. So when you take this information and you actually apply it, you can find these values. So these are what we call quadrangle values because they're units of 90. So let's say that I have a coordinate plane with a unit circle on it, and I want to go all the way over to there. So it's actually, I'm sorry, I went the wrong way. Because it's a negative 180, it's going to end on the same spot. So you're going to go all the way to here. Well, if you have a unit circle and you think of your x and y value there, your x value there is negative 1, and your y value is 0. That is the point, negative 1, 0. The cosine of 180, negative 180, remember your cosine is your x, your sine is your y. So the cosine of negative 180 is negative 1, because that's my x value. If I had the sine of negative 90, then I'm going down here. So I'm right there on my unit circle, which that ordered pair is 0, negative 1. I'm looking for the sine, which is my y value, which is going to be negative 1. X is cosine, y is sine. I'm looking for the secant of 90. 90 is up here. So the ordered pair is 0, 1. Remember, the secant is the same as 1 over the cosine. So 1 over the cosine of 90, the cosine of 90 is 0. So I have 1 over 0, which is empty set or undefined. It can't be done. I can't have 0 on the bottom. Cotangent of 270. 270 is all the way around to here. So that is the value on the unit circle of 0, negative 1. The cotangent is going to be, if you will, it's going to be the x over the y, based on what we just learned on the last page. So the x value here is 0, The y value is -1, so my answer is 0. The cotangent of 270 would be 0. So I can use my unit circle to find 6 trig functions. Now, these are not the ones that are based on 90. So this particular one is going to be based on 45, 45, 90 special case triangle. So to just refresh your memory, this is something we've done in the past. If I have a 45, 45, 90 degree triangle, then the side opposite both of my 45s, we'll call it x, they have the same value. And then the hypotenuse is going to have the value of smiley face on the square root of 2. When we learned it, I think we used smiley face rather than x, so we wouldn't get mixed up. So these two have the same value. If those values were 2, then that would be 2 on the square root of 2. So if I do my coordinate plane with my unit circle on it, 135 degrees is going to be 90 plus 45 more. Okay, so now I'm going to look for my reference angle, which is also going to be 45 degrees. Okay, now if I'm in my second quadrant, the x value is negative and the y value is positive because it's in my second quadrant. So I have a 45, a 45, and then remember this is equal to 1. So if you will, 1 is equal to smiley face on the square root of 2. So I've got to divide both sides by 2, but then I have to rationalize my denominator. So I'm going to multiply the top and the bottom by the square root of 2. And I'm going to get smiley face is equal to the square root of 2 over 2. Okay? So therefore I know that this point right here is a negative square root of 2 over 2. Okay? Because that's opposite that 45. And this one is opposite the other 45. So this side right here is a negative square root of 2 over 2. And this side right here is a positive square root of 2 over 2 because that's what smiley face is equal to. All right, so if I know that, then I can figure out my 6 trigonometric functions. So I've got if my x value, this is probably the easiest way to do it. Your x value is a negative square root of 2 over 2. Your y value is a square root of 2 over 2. And of course your hypotenuse is 1 here. So I'm going to have sine of 1, let's see, what was it, 135 is equal to a negative, or a positive, square root of 2 over 2. My cosine at 135 is going to equal to a negative square root of 2 over 2. My tangent at 135 is going to equal to negative 1 because I'm going to place this over this, or the x over the y. They're the same thing, but one's negative and one's positive, so it's going to be a negative 1. Then to switch these, the cosecant of 135 is going to be the inverse of this. So it's going to be 2 over the square root of 2. But I have to rationalize my denominator. So it's going to be 2 on the square root of 2 over 2, or square root of 2. My secant is going to be the inverse of this, which obviously it's going to be a negative square root of 2, because you're going to go through that whole thing again, but I have a negative on it. And my cotangent of 135 is going to be a negative 1, because it's negative 1 over 1, which when I flip it, I get the same thing. All right, let's do 210. On 210, we're going to use a 30, 60, 90 triangle. So refresh your mind on this one. Okay, so the side opposite my 30 is a smiley face. The side opposite my 60 is a smiley face on the square root of 3. And my hypotenuse is 2 times smiley face. Okay, so let's put this on a unit circle. $210 would be 180 and then 30 more. So my reference angle is going to be down here. Now, this is in the third quadrant, so it's going to be a negative and a negative. Okay, so I'm sitting here, I'm going to go, okay, at 30, remember the side opposite, it is my smiley face, but my hypotenuse, because it's a unit circle, is 1. So 2 times smiley face is equal to 1. So smiley face is equal to 1 over 2. So the side opposite the 30, which would be your y value, is a negative 1/2. Okay? Your x, which is going to be the smiley face on the square root of 3, is going to be 3 times 1/2. So it's going to be the square root of 3 over 2. Okay, because remember the smiley face is 1/2, so I would multiply it 1/2 on the square root of 3. So this is your 60 degree. Okay, so this is a negative square root of 3 over 2. And then this is your 30, which is going to be a negative 1/2. So that's why we got the x is the square root of 3 over 2. The y is negative 1/2. So I know those values here. X is equal to the square root of 3 over 2. Y is equal to negative 1/2. So the sine of 30, actually the whole thing is 210 degrees. So the sine, remember, is the y, so negative 1/2. Your cosine of 210, that's going to be your x, square root of 3 over 2. Your tangent is going to be the y divided by, so 1/2, divided by your x, which is square root of 3 over 2. When I flip this, I'm going to get negative 2 over 2 on the square root of 3, okay, because I'm going to flip it and multiply. So I'm going to get a negative 1 over the square root of 3, which is equal to a negative square root of 3 over 3. Now, when I reverse them, the cosecant of 210 is going to be a negative 2, because I'm flipping that. The secant at 210 is going to be 2 over the square root of 3, and it should be negative here, which means that's positive, because they're both negative. I don't know why I didn't put that other on there. Okay, so it's a negative square root, or 2 over the square root of 3. I'm going to rationalize it. So I'm going to get a negative 2 on the square root of 3 over 3. And then to do my cotangent, it's going to be the reverse of this. So it's going to be a 3 over the square root of 3, which I have to rationalize it. So it's going to be a 3 on the square root of 3 over 3, or simply a square root of 3. Okay? So that would be your 6 based on those. Now, you don't always have a unit circle. So sometimes you might have something that has a bigger radius than 1. So let's say I've got something here. We're going to call, this is the point xy, or cosine, sine, and this would be my x value, this would be my y value, and this would be my r value. R is going to be your hypotenuse. So your sine is going to be y over r. opposite, so if I'm standing here, opposite over hypotenuse. Your cosine is x over r. Your tangent is y over x. That hasn't changed. And then these would be the reverse of it. Oops. It's r over y. It looks like a x. R over x and x over y. Okay, so it's important to know those. We're going to take that and we're going to apply it. Okay, I'm going to find 6 trig functions for an angle that's in standard position if a point with a coordinate of 5, negative 12 lies on its terminal side. So the first thing I'm going to do is I'm going to draw this thing out. So I have this point right here. So I am going to come around and I'm going to come around to there. Now, I didn't draw that real good, but so that's going to be my reference angle. If it's in the 4th quadrant, then my x value is positive and my y value is negative. Now, I already know this point. This is the point 5, negative 12. So this is 5, this is negative 12, and all I would have to do is the Pythagorean theorem to find what that point is. So x is equal to 5, y is equal to negative 12. Now, your r is always going to be positive because I'm always going to use those two. So 5 squared plus the negative 12 squared is going to give me 169. And I'm going to take the square root of it, which is going to give me an r value of 13. So I did the Pythagorean theorem on this. This squared plus this squared equals this squared. So now I have all the information I need to find the sine of theta, the cosine of theta, the tangent of theta, the cosecant of theta, the secant of theta, and the cotangent of theta. So remember, sine is y over r, so negative 12 over 13. Cosine is x over r, so 5 over 13. And tangent is y over x. So it's just like filling in based on what we've already discovered, based on that information. Okay, based on that information, then I'm coming through and just filling in. So then these are flipped, so negative 13 over 12, 13 over 5, and 5 over negative 12. Okay, let's do another one of those. All right, let's say we have negative 15, 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so approximately right there. So this is what I have. This is going to be my reference angle. So based on this, I know this is negative 15, and this is going to be positive 20, because this is my x, this is my y. Now, in order to find my r, I do Pythagorean theorem on this. So I do 20 squared plus 15 squared, because you know that it's going to lose the square root. And then I'm going to take the square root of that, and I'm going to find out that the r is 25. So x equals negative 15. Y equals 20. R equals 25. So the sine of theta is negative 15 over 25, which I would have to reduce. to negative 3 over 5. The cosine of theta, oh wait, I did that backwards. It should have been 20 over 25. Sorry about that. So I'll divide both by 5, so I'm going to get positive 4 over 5. This one is negative 15 over 25, which is going to give me a negative 3 over 5. And this one is going to be 20 over negative 15, or let's see, I'll divide them both by 5, so 4 over negative 3. And then I just have to switch them. So cosecant of theta is 5 over 4. Go ahead and flip the ones that are reduced down. The secant of theta is negative 5 over 3. And the cotangent of theta is negative 3 over 4. Okay. All right, then the last information in this particular section, they will give you one trig function and a quadrant that it's in, and they'll want you to find the rest. So they tell me that the sine of theta is negative 4 over 5. Well, I can look at that and I can go, I could draw it on a coordinate plane, not that I have to, but that's going to be negative 4 is going to be my x value, and 5 is going to be my hypotenuse. Now it says it's in quadrant 3, so it's down here. So if you will, I have a negative 4, and I have the hypotenuse is 5, because remember, well, actually the negative 4 would have to be over here if it's down there, because I'm talking about sine, so it's opposite over hypotenuse. So I would have to find the adjacent. If you do that, you're going to do Pythagorean theorem, but you're going to do 25 minus 16, which is 9, to the square root of 9 is negative 3. Now, if it's in the third quadrant, you know that both of those are negative, the x and the y. I could just list this out. X is negative 3, y is negative 4, and r is 5. Now I just have to go through and list all my trig functions. So I've got sine is y over r, so negative 4 over 5. Cosine is x over r, so negative 3 over 5. Tangent is y over x, which is negative 4 over negative 3, which is 4/3. Flip it, you have 3 over 4. You have 5 over negative 3, and you have 5 over negative 4. All right, let's do one more, and then I'll give you your homework. Okay, so if you've got a secant, if you think about it, the secant is 1 over the sine, or the inverse of sine, so, or the inverse of cosine. So this is going to be the x, because the cosine is x, and this is going to be the r, or the hypotenuse, okay? So all I would have to do is I would have to find the y. If I put it on a coordinate plane, it tells me it's in the fourth quadrant. So my x value is 5. And my y value is unknown right now. So this is 5. And this is on the square root of 29. Now, my y value is going to be negative because it's in the fourth quadrant. So what I'm going to do is I'm going to take Pythagorean theorem, so 5 squared plus my question mark squared is equal to the square root of 29 squared. So I have 25 plus question mark squared is equal to 29. Subtract the 25. So I have 4. So I know that the y value is equal to a negative 2, because remember, it's in the fourth quadrant. Square root of 4 is 2, but I know it's in the fourth quadrant. So I've got x is equal to 5, y is equal to negative 2, and r is equal to the square root of 29. So sine, cosine. I'm going to leave a little bit more room because we have a square root in here, tangent. And I have cosecant, secant, and cotangent. All right, so I have y over the square root of 29. I have to rationalize, so I have to multiply the top and the bottom by the square root of 29. So I'm going to get negative 2 on the square root of 29 over 29. Now, when I go to invert it, I can invert just this one. So it's going to give me the square root of 29 over negative 2. Okay, your cosine is 5 over the square root of 29. I have to multiply the top and the bottom by square root of 29. Hope you remember how to do all that. So it's 5 on the square root of 29 over 29. And I'm going to invert that. So it's going to be the square root of 29 over 5. This one is going to be y over x. And so when I flip it, it's x over y. Okay. And your homework on this is page 296 through 297, 14 through 44 even, but don't do 36.